People living in equatorial Africa are living in a hot environment. The skin must have been able to sweat very efficiently so that people could keep cool. And also because that skin was naked and therefore was prone to damage from ultraviolet radiation. And so the skin of our ancestors was dark, full of the natural sunscreen, melanin.
Sunlight produces vitamin D, We are all very much alike. Our DNA shows that we come from one very small gene pool.
If we look at the DNA of all of us, Australians, Africans, Europeans, we find that comparing the mitochondrial DNA of all of us, we show less variation. Even though there are billions of us and we're spread over the whole world, we show less variation in our mitochondrial DNA than we would find in, say, a small group of chimpanzees or orangutans or gorillas. Those apes show more variation, even in their small groups, than the entire human race shows.
But if all the people from around the world descend from such a small gene pool, why do we all look so completely different? Natural selection and adaptation to the environment are the most important factors. Sexual selection is crucial. Climate dictates body shape. The colder the environment, the shorter and more stocky you become to retain heat. Height relates to diet. The most obvious and striking difference is color. And that's also a part of our genetic inheritance. Nina Jablonski, a leading scientist looking at the evolution of skin color, was working on the importance of folic acid in fetal development when she stumbled by chance on the answer.
I started doing research on the evolution of skin color after preparing a lecture for a class over 10 years ago. It was interesting, preparing for the class, I realized that there was very little that was known about the evolution of skin color, and what was known wasn't very cogent. I discovered an interesting paper when I was preparing that lecture that showed that there was an interesting and important relationship between ultraviolet radiation and a very important biomolecule called folate.
Folic acid is crucial for embryonic development, and too much ultraviolet radiation from the sun destroys it. So our ancestors in tropical Africa needed to be dark to protect their survival. But too little ultraviolet prevents the formation of vitamin D, causing rickets, which can kill. So as they migrated to the sunless north, they had to grow paler to survive. She has uncovered a very simple evolutionary equation.
When we look at the pattern of skin pigmentation among indigenous peoples today, we see very dark people in equatorial regions with high UV, and significantly lighter people as we get toward the poles. And it turns out that melanin, the natural sunscreen, is phenomenally good at screening out ultraviolet radiation. To some extent, it's too good. And in order for us to be able to make enough vitamin D in our skin, we have to reduce the amount of melanin that exists in the skin. And so what we see in the course of our species history, as we've moved from an area of high UV to areas of lower UV, our skin has become more and more depigmented.
She calculates that it takes about 20,000 years to turn from black to white. All that distinguishes color in people are tiny genetic differences laid down long ago.
The evolution of darkly pigmented skin in the early members of the genus Homo, evolving in equatorial Africa, was extremely important. And we have circumstantial evidence from levels of activity in fossil hominins. We know that these were active, striding, running bipedal people with functionally naked skin, very sweaty skin. They would have needed some protection against the sun. The protection was melanin. And we also know from recent studies looking at the genes controlling pigmentation that one of the main genes controlling pigmentation is present in an invariant form in modern African populations. In other words, in the terminology of geneticists, it has undergone purifying selection so that there are no variations in this gene.
This particular morphology, functionally hairless skin that is darkly pigmented, is the ancestral morphology for our Homo lineage, more or less for the last 2 million years. And all of the derivations that we see of moderate to lightly pigmented skin started out really from this phenotype. And this is, I think, a very, very important revelation. Now, darkly pigmented skin works extremely well under high UV regimes. As I said, it is a natural sunscreen. Well, what is it protecting you against? What exactly does ultraviolet radiation do that makes it so bad for humans? We know that it's generally bad to biological systems.
Go. 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 Go.
Professor Christopher Stringer, Britain's leading paleoanthropologist, was involved in the dating of the earliest modern human skulls.
This skull is as close as we can get to what the face of mitochondrial Eve would have looked like. It's a very complete skull found in sediments in a cave dating from about 120,000 years ago. And we can see here that it's a modern human. We've got a high rounded vault to the skull, a face that's tucked in under the cranial vault.
And this is what she looked like. Using forensic reconstruction techniques, muscle and flesh have been added to the skull and provide us with the very first glimpse of how our genetic mother might have looked 150,000 years ago. In 1987, Kahn and her colleagues published a paper showing for the first time that the markers stretched back to Africa, showing quite clearly that this was the birthplace of the human race. New Guinean tribesman, Parisian bartender, American teacher, Polynesian farmer, all were improbable relatives linked through one black woman 150,000 years ago.